acids and Zwitterions. So basically just know that they exist as Zwitterions. So what that means is that that H comes over here. So I'll draw that out, this H, left with the negative charge here because the H dipped. New H is on here, and because you had another H, this gets a positive charge. And that right here is called Zwitterion. Okay, that just needs to be known. Just to memorize that structure, memorize the original amino acid structure, and then how you end up with the Zwitterion. Okay, then how Zwitterions actually work. So imagine this is a Zwitterion for aspartic acid. Let's just say, by the way, these are all in section 33 of the data booklet. So let's say it's aspartic acid. Now what you need to look at is the isoelectric point, and of aspartic acid is 2.8. Now the question will tell you what pH of solution or whatever it's been put into. So this value doesn't change, by the way. So the isoelectric point of amino acid, this thing, will always just be what it is. So we have, oops. Okay, here's my beaker. And in this is a pH 5 solution. Okay, and I put my aspartic acid inside here. So what happens when the aspartic acid goes in is, since the isoelectric point is 2.8, but the pH of, and that's 2.8 pH, that's the pH value, is pH 5, okay, every amino acid or Zwitterion wants to get this solution to its isoelectric point. So if it's at 5 and it wants it to be 2.8, it wants the solution to be more acidic. And the way the Zwitterion achieves the solution becoming more acidic is just giving off H's. Because right, that's like what pH is, that's what acidity is like the concentration of H plus ions. So aspartic acid gives off this H. That positive charge is lost, and it ends up being negative overall, and we show that. We can just draw a square bracket with a negative charge because it wants to get this pH 5 to 2.8. It wants this to become 2.8, so it's going to give off H's to make this more acidic. Okay, say we have this Zwitterion, and let's say it is, what's a common one? Actually, I don't know how common any of them are. Let's just say it's arginine. Okay, this has a pH of isoelectric point of 10.8. Okay, let's say again, it was put in, the question says it was put into a beaker pH 6 solution. Okay, so every Zwitterion wants the solution, it wants the solution to become its isoelectric point, because this is what they're comfortable at. So that's what they're going to try and make the solution become. So if you're a Zwitterion that likes a pH of 10.8 and you're put into pH of 6, you're going to try and make that solution more basic. You're going to try and get it up to this basic 10.8. To make a solution more basic, you take H plus out of the solution. So it is going to take up H plus. So the H plus is swimming in the solution. Here they are, take up onto here. Which means that loses that negative charge. There's no negative charge over here anymore. And the thing becomes overall positive, because we can see that here. So that's basically all there is to know